Good afternoon, guys. We are on our next to last set of notes for this class, and you can see we're talking about the properties of logarithms here. So yesterday we looked at logarithms and exponentials and how the two are related. Today we're going to expand on some of the more important properties of logarithms that you may have encountered them on the ACT, for example. And traditionally on the ACT they may give you these properties for you to apply. Today we're going to look at all of them together and learn how to work with them. The first thing we're going to do with example 1 is just kind of a refresher from yesterday. It says show that log base a of 1 is equal to 0. Well, we know that we can rewrite a logarithm as an exponential, and we just simply take the base of the logarithm, we raise it to this power, and it's going to be equal to what we're taking the log of. So we already know that a to the 0 power is equal to 1. Anything to the 0 power is 1. So we've just simply taken the logarithm, rewritten it as an exponential. We know that the exponential is true because anything to the 0 power is 1. So then that implies that the logarithmic property that we have illustrated for part A is true as well. For part B, very similar process. Take the base of the logarithm, raise it to this power, and it's going to be equal to what we're taking the logarithm of. Well, anything raised to the first power is itself. So we've created a true exponential statement, and we know that that logarithm has to be true. So some of the properties that we will apply from time to time with logarithms is if we have an exponent with a base of, in this case we'll call it a, and it's raised to a logarithm that has the same base, the end result is simply, you can don't process it this way, but you can think of it this way. This a and this log base a cancel each other, and all you're left with is that m. So you take a base, raise it to a logarithm of the same base. Essentially whatever you're taking the logarithm of is what that's going to be equal to. And then similarly with the exponents, log base a of a to the r power is simply just going to be the log base a of a. That is 1. And one of the properties we're going to see here in a minute is that this exponent becomes a coefficient. So this is the same as saying r times 1, which is just going to be r. And we'll apply these properties here in example 2. So we have a base 2 exponent raised to a logarithm of the same base. So we just get pi. 2 raised to the log base 2 of pi. We just are left with pi. Log base 0.2 of 0.2 raised to the negative square root of 2 power is negative square root of 2. And then natural log of e to the kt. Remember yesterday we talked about the natural log. That is the same as a log base e, which we don't traditionally write, but I'm just writing this out to illustrate this point for you. Log base e of e to the kt, same property as what we saw in part B. All we're left with is kt, because the base of the log and the exponent are the base of the exponent are the same. This is kind of the real meat and potatoes of properties of logarithms, and this is the one where we have to do the most application, and we have to be more cautious with our algebra steps. The first property that's illustrated here, essentially we take logarithmic multiplication and we can rewrite it as logarithmic addition. The opposite is also true. We can take logarithmic addition and write it as logarithmic multiplication. Then we will move down to logarithmic division, which becomes subtraction, and again subtraction can also become division. And then we have these two properties right here. The log of a power equals the product of the power and the log. So we have the log of a power, log base a of m to the r, is equal to, we just take this exponent r and we bring it down as a coefficient. So that's equal to r times log base a. And then the other property here deals with natural logs. We have a to the x. If you have e to the x times the natural, or e to the x times the natural log of a, you can just take this a and raise it to that power, and you have the consolidated or the reduced form of that exponent. With example 3, we're going to apply this first property. logarithmic multiplication equals logarithmic addition. What we have in example 3 is x times the square root of x squared plus 1. So to write that as logarithmic addition, we just take log base a of x plus log base a of the square root of x squared plus 1. The other note that's on this particular question says express all powers as factors. At first glance, you might say that there are no exponents here to express as a factor. But keep in mind, we can write square roots as exponents. So the square root is the same as the 1/2 power. So now we have an exponent that we can bring down front as a coefficient. And so our final answer would be log base a of x plus 1/2 log base a of x squared plus 1. And that's as far as you can go with this particular problem. We've written it out as the sum of logarithms, and we've made all of our exponents factors, and so we're complete on this particular example. With example 4, we're applying that second property where we're taking division and writing it out as subtraction. So we would first begin by taking the natural log of x squared minus the natural log of x minus 1 quantity cubed. Again, we want to bring all powers down as factors. So we have this x squared. So this would become 2 natural log x minus, and then we have this 3 in the exponent. So it's minus 3 natural log of x minus 1. And we have simplified that one as far as we can go as well, or expanded it as far as we can go. With example 5, we're going to kind of put properties 1 and 2 together. We're going to do some subtraction and addition. So the first thing that we want to get rid of is the division right here. So that's going to indicate that we have to first write it out as subtraction. So we have log base a. And I'm going to go ahead and save a step and write this as log base a of x plus 1 to the 1/2 power. We're going to get rid of that square root, change it to an exponent, minus log base a of x cubed times x plus 1 to the 4th power. On the left-hand side, we can pull that exponent down front as a coefficient. So we have 1/2 log base a of x squared plus 1 minus, right here between these two terms we have multiplication, so we can write that out as addition. Because the addition is occurring on the right hand side of this minus sign, let's put this whole thing in a bracket so that should we try to evaluate it or whatever, we know that that negative has to distribute through the entire quantity. So we get log base a of x cubed plus log base a of x plus 1 to the 4th power. And there in the brackets, the only thing we have left to do is to pull all those exponents down as coefficients. The left-hand side, we don't have to do anything else with it. It's completely finished. So then that becomes 3 log base a of x plus 4 log base a of x plus 1. And we have expanded that logarithm as much as we can. And all of our powers are expressed as coefficients, and we're done. We've used the subtraction and addition properties of logarithms as well. Example 6 is the last example on here, and there is a typo. This should not be an equal sign. That should be a minus sign on part B. So for part A, let's do it first. It says write each of the following as a single logarithm. So we're doing just the opposite of what we've done in the previous examples. We're taking the logarithms and we're condensing it down into one single logarithm. For part A, the first thing we look for are coefficients. So our coefficients become exponents. So we can write this as log base a of 7 plus log base a of 3 to the 4th power. 3 to the 4th power we can further simplify. It's going to be 81. So we get log base a of 7 plus log base a of 81. And to condense addition, we use multiplication. Log base a of 7 times 81, which is going to be log base a of 567. And there is the condensed logarithm of what we started with for part A. We're going to do the same thing with part B. I did change that to a minus sign there. So first thing, we take any coefficients and make them exponents. So this is natural log of 8 to the 2/3 power minus natural log of 5 squared is 25. 25 minus 1 is 24. And for this natural log of 8 to the 2/3 power, we can take that fractional exponent and write it as a radical. The denominator tells you what type of radical it is. So this is going to be a cube root of 8 squared. So we have natural log of the cube root of 8 squared minus natural log of 24. 8 squared is 64. The cube root of 64 is 4. And so we have the natural log of 4 minus the natural log of 24. Subtraction becomes division. And we still reduce fractions just like always. So 4 over 24 is 1/6. And we end up with the natural log of 1/6. Part C looks like a booger, but it's really not that bad. First, we go through and look. We don't have any coefficients that we can eliminate. We don't have any parentheses around any of our logarithmic properties. So since it's all strictly addition and subtraction, we simply read it left to right based on what the order of operations tells us. So the first thing we want to do is take this term and condense them through logarithmic multiplication. So we have log base a of 9x plus log base a of x squared plus 1 minus log base a of 5. Again, in the absence of parentheses indicating that two logarithms need to be put together first, we just read it left to right. So we have this term plus this term, so that means we multiply again. So we get log base a of 9x cubed plus 9x minus log base a of 5. The last step, we have logarithmic subtraction, which implies logarithmic division to condense it. So we get log base a of 9x cubed plus 9x over 5. And that is the condensed form of that ugly logarithm we started with for part C. So here are your suggested problems. I really do suggest you look at these. This is all algebra. This is not calculator work at all. You shouldn't need a calculator for any of this. It's just to ensure that you understand the algebraic steps. Problems like this will be on the final. So make sure you do know how to do these. Look through a few of them. If you get stuck, ask me questions. I'll be happy to answer them. The other thing too is we will be meeting later on this afternoon to discuss the final. So everybody plan on that 2 o'clock Zoom meeting, and we will talk about when we'll do the final. It'll either be Friday or we'll do it on Saturday, but we have to come to an agreement. I know some of you have jobs and things like that, but we have to have the same 2-hour window for every single person in the class. I can't let some of you take it from 10 to 12 and then some others take it from 1 to 3. Everybody has to do it in the same 2-hour block, so that's what we need to discuss. I hope everybody's doing well, and I will be talking to you later on this afternoon.